Hello everyone. Today we will start our lecture on microprocessor 8086. Now we're in the chapter 1 and our topics is microcomputer system. This one is the generation of microprocessors. Here in first we have, which was in the 1971, the name of the microprocessor was 4004, which size was 4 bit. Then from the 8008 we have the 8-bit microprocessor. The first 16-bit microprocessor was the 8086, which we will discuss in this section. The 32-bit was the 80286, and after that the Pentium Pro comes with the 32-bit of processor in 1995. Then it goes and goes. But we first get the 64-bit, which is the Intentium on 2001. This is the short description of microprocessor generations. First, the block diagram of microcomputers. Here in this section we have the memory, the input output, the control unit, which is known as the CPU. This one is the diagram. Here in this central section we have the central processing unit for processing the data, and in the output and input port, which is known as the I/O port, here we have I/O devices, means the input devices, and this one is for the output devices which are connected with the input output ports. Then the data bus is bidirectional, which is connected with the input output port, CPU, which is central processing unit, and the memory section, which is with the RAM and the ROM. Here the address bus is also unidirectional. That's the reason those arrows are in one direction. Here we have the most important thing, which is the address bus. The address bus consists of 16, 20, 24 and 32 parallel lines. On those, it will send the address of the memory location to the CPU that are to be read or write. The location of CPU are sent by the address lines, and the memory location can be denoted as 2 to the power n. That means if the address line is 5, then the memory location can be 2 to the power 5. Here we have used the address line, which is 16-bit. So the address of memory location can be 2 to the power 16, which is 65536 memory location. That means 64 kilobyte of memory locations. In this data bus section we can have 8, 16 and 32 parallel signal lines. Those data bus are bidirectional. Those are used for carrying data. Now the control bus. In the control bus, it consists of 4 to 10 parallel lines. The CPU sends the out signal, and the control bus enables the out address of the memory device or port devices. That means control buses are to carry the control signals mainly, which can used for read write on I/O and memory sections. Now the hardware, software and firmware, those are not very important and you have a basic idea of them. Now the instructions on 16-bit microprocessor. Here in the 16-bit microprocessor, families are designed to primarily to complete the microcomputer and are the originated and two-word high-level languages. That means they are close to the high-level languages. In this section we can see that this diagram and this picture, it says that how many pins each of the microprocessor has. The primary objective of 16-bit microprocessor is to increase the memory address capacity, because previously are for the 8-bit, this is the 16-bit, so the memory address is increased because the memory address now becomes 2 to the power 16, which is 64 kilobytes. It is used to increase the speed because the memory address is increased, so the execution speed is also increased. It provides a powerful instruction set. Now, facilitate the programming of high-level language because the memory address is increased and the execution speed is also increased. That's the reason the programming of high-level languages can be done easily. 8086 microprocessor has 16-bit data bus, 20-bit address bus, a control bus, execution unit, and a bus interface unit. Those two units divided the 8086 into two parts. Here are some features of 8086. This is also a 40-pin but dual inline package, which is in short DIP, is used in 8086. It have three versions: 5 MHz, 8 MHz, and 10 MHz. Block diagram architecture of 8086 microprocessor. Here we have two independent function parts: the bus interface unit, which is known as BIU, and the execution unit, which is known as EU. I have already told you that those two sections will divided the 8086. Now this is divided into two sections. One is BIU and one is EU. Now by this diagram you can easily see that this one is the executional unit, which is known as EU, and this one is the bus unit, which is as the bus interface unit is BIU. Now we are in the execution unit. Those units are very important. In this execution unit we need to execute the instruction and consist the circuit, which is called the ALU, which is for the arithmetical operation like as addition, subtraction, multiplication, and division, and also some logical functions such as AND, OR, NOT, etc. Here in the executional unit we have 8 registers. Those are AX, BX, CX, DX, SI, etc. We will discuss them in later. Here we have a general purpose knowledge about those registers, that AX, BX, CX, and DX are the data registers. Then SP and BP are the pointer registers, P for the pointer, and then SI and DI is for the index register, I denotes the index. This diagram is very important for your exam question point of view. Please have a snap of this one for your further study. In this executional unit you have some registers. The internal bus is connected with the both unit. Here you have the temporary registers, the arithmetical logical unit section, and then the flag section. That means in this bus interface unit section you have the segment sections, and then the control logical section, which controls the logic, and then the queue, and by that the ALU works and generates the flag and temporary stored in on the registers. Now the bus interface unit, which is known as the BIU, which is bus interface unit, it is to communicate between the EU and the memory or IO circuits. Its registers are named as CS, OS, ES, SS, and IP. Here the most important one is the IP, which is known as the instruction pointer. It means which instruction is going on is to be pointed by the instruction pointer. It contains the address of the next instruction. That means you are now performing the A instruction, but your next instruction is B. So instruction pointer points to the next B instruction. That is how after finishing your A, you just move to the B. That is why the instruction pointer is very important. Now the instruction queue. To increase the executional speed, the queue is generated. In this section, there are parallel instructions are situated, and after they move on. So the instruction queue is for the queuing function. Then the instruction pointer. We have already discussed about instruction pointer. It have 16-bit address of the next code byte within its code segment. First of all, we need to fetch and execute the cycle. A machine instruction have two parts, opcode and operand. We have already discovered here those topics in 8085 section. Opcode is the operation code. That means addition, multiplication, etc. And operands are those two needs to be added. That means A, B needs to be added. So A and B are the operands, and addition or add is the opcode. Here we have two functions. First, we need to fetch the instruction from the memory, then decode the instruction, then fetch the data from the memory. In this execution section, perform the operation, then store the result. Those are the functions of fetch and execution. This is the diagram of fetching and execution in cycling. You can see that here fetch, execute, fetch, execute, fetch, execute. That is how the fetching and execution cycle is moving on. Fetch the instruction, then decode instruction, then fetch data, then perform the operation, and then store the data. That is how they works. By this you can see that BIU is on the fetching section, that every time it fetch the data, and in executioning section it executes the data. That is how BIU and EU are related to each other. If the BIU doesn't fetch the data, then the EU needs to wait section. That's for today. Thank you.